We're going to look at example 2 of proving whether or not a function is even. This time we have f of x is equal to secant of x plus pi over 4. Now if you recall, here are our even and odd identities, and over here we see that secant of negative theta is equal to secant of theta, so it's even. However, be cautious because there is an alteration here with the secant function. It says x plus pi over 4, so we can't assume it's even. Now recall, to prove it's an even function means when you plug in a negative number, do you get the same result as when you plug in the positive version of the same number? So here's the thing. We would normally look to use cofunction identities like we did with example 1 in the sine function. However, with the cofunction identities, they're in terms of pi over 2, not pi over 4. That should send off a red flag, okay? Typically, when you have a shift of pi over 4, it's going to alter the function in such a way that it's probably not going to be even anymore. I'm just going to be honest with you. However, how do we actually prove that it's not even? Well, fortunately, when you're proving that something is not even, all you have to do is find out a case in which it's not true. In other words, we said that when you plug in a negative number, you have to get the same thing as when you plug in a positive. So if I plug in negative pi over 4 and figure out what y is, I should get the same answer back as when I plug in positive pi over 4, right? I would get the same f of x value back. If not, then it's not even, right? It has to be true for all x values. If I've proven for one doesn't work, then it can't be an even function. It has to be true for all. Okay, now step 1, we're still going to go through the same steps. We're going to see if there's any way we can simplify this whatsoever. But in fact, there's not any identity we've learned does not involve pi over 4 as far as I know. You can try as much as you want, you're not going to get anywhere. So we're just going to have to leave it that way. That's why it says if possible. Okay, step 2. We definitely have to plug in negative x. So f of negative x is equal to secant of negative x plus pi over 4. Our next step would be to seek to simplify this expression. Now, the thing is, we can't really simplify this expression. If we try, for example, to pull a negative out of here, well, actually, let's go ahead and just do that, okay? Now, you don't have to do this with me because, like I said, you can prove by just plugging in a number that won't work. If you perceive, for example, that it's not even, you can go ahead and do that. Whoops. What you're going to do is pull a negative out inside. This is another tactic you can use. So basically what I've done, make this look like an x, I've pulled this negative out from the x, and I've had to change the second term to negative. Notice if you distribute it, you'll get the same thing up here. So like I said, this is an effective method that will work sometimes for even functions. And now we know that secant of negative whatever just ends up becoming the positive version of that, right? Because, for example, if this was theta, secant of negative theta is secant of theta. Why? Because as we said before, secant is even. So we'll just imagine that x minus pi over 4 is theta. Okay, so we're going to write this as f of negative x is equal to secant of x minus pi over 4. The negative goes away because secant is even. But however, f of negative x is secant of x minus pi over 4. But look what we started with, secant of x plus pi over 4. So perhaps this is a proof that secant is not even, right? Because let's think about this, for example. If you add pi over 4 to an angle, are you going to get the same secant value every time as when you subtract pi over 4? Let's take a look. Okay, let's actually look at the unit circle in radians, if I can find it. Okay, so for example, let's start at this angle 0. If I add pi over 4, there's my x value, which is what secant depends on. If I subtract pi over 4, oh, I do get the same x value. Maybe it is even. However, we know that's not the case, and here's why. Let's start at 90. If I add pi over 4, my x value is negative square root of 2 over 2. If I subtract pi over 4, it's positive square root of 2 over 2. So secant of x plus pi over 4 does not always equal secant of x minus pi over 4. Now, like I said, you can actually go a step further here and just prove it for a particular x value. I started at the beginning by discussing plugging in pi over 4. So let's go ahead and do that. Actually, before we go into plugging in a specific angle, let's go ahead and finish this problem out, and then I'll show you the alternative way. Okay, so we've shown that f of x, which was original, is secant of x plus pi over 4. We've just shown that f of negative x is equal to secant of x minus pi over 4. And we've gotten some clarification by looking at the unit circle and knowing that those aren't the same thing. So for our final example, we can say f of x does not equal f of negative x. So f of x is not even. Okay? Now here's the alternative way, and I'm just going to show you down here. I said we could plug in a specific angle. So let's plug in pi over 4. Okay? Now remember, and I'm plugging in pi over 4 because it already has a pi over 4 in it, and I found f of negative x is x minus pi over 4, so that's just going to become 0. So this is going to be very easy to prove. Okay, so first of all, I'm going to plug in pi over 4 to the original. Whoops. So it's going to become secant of pi over 4 plus pi over 4. Does anybody know what pi over 4 plus pi over 4 is? It is, let's do red again so we're clear here. Pi over 4 plus pi over 4 is pi over 2. And what is secant of pi over 2? Well, the x value on the unit circle, let's go ahead and look at that real quick. You should know it by now. The x value on the unit circle is 0. Secant is 1 over x, so it's going to be undefined. Okay, so you can already tell that something's not right here, right? Whoops. Okay, so let's do f of negative pi over 4, right? Okay, we'll be plugging that into the original function because we have to show f of negative x and f of x are not equal to each other. So obviously, negative pi over 4 plus pi over 4 is just 0. Okay, and going back to the unit circle, the x value 0 is 1, secant is 1 over x, so secant is 1. So final answer for this, f of negative pi over 4, I wish my handwriting was quicker and more neater, is equal to 1. Well, what's the problem? We showed that f of, whoops, let's not do that. Okay, we've shown that f of negative pi over 4 is 1, but f of pi over 4 is undefined. So f of x, in this case pi over 4, does not equal f of negative x. 1 is undefined. F of pi over 4x is undefined. F of negative pi over 4, f of negative x is 1. So therefore f of x, which is undefined, does not equal f of negative x, which is 1. So yes, you can prove by contradiction. However, there's a huge caution there. You cannot prove, if you plug in the, let's say we plug these two in and we say we got 1 for both, we can't just say that's even. You've got to prove it for all. So I would just give you caution if you're going to prove by contradiction. Perhaps you could look at the graph first. So let's look at the graph. All right, we can see here's our graph. It is not even. It is not symmetrical about the y-axis. In fact, the symmetry looks like it's closer to somewhere between 0 and 1 right here. Okay, so the real way to prove this, really, I would say, is this way, is to show that secant of x plus pi over 4 does not always equal secant of x minus pi over 4. And you might make a note about that on the unit circle and list a particular angle where it isn't true. So maybe both methods put together kind of give the most clarity in terms of why this function is not even. Okay, that's it for this example of proving that a trig function is not even. If you have any other questions about it, let me know.